At Ariadne, we build algorithmic data infrastructure for banks. Our software enables banks to overcome costs and inefficiencies involved within the data warehouse solutions. Our ecosystem comprises of universities in Switzerland, development partners in India and the US. We are incubated by Thomson Reuters in Switzerland. In order to start analysis on Ariadne, we require the information of the deals that a bank has signed up with their end clients. Such information would be no hassle for banks to provide, which contains info such as contract type, the notional value of the deal, start date, end date, currency, etc. Here is where the machine learning kicks in. In Ariadne, such information is converted into self-executing algorithms. These algorithms include mathematical expressions or formula used to calculate the deal. When we trigger such an algorithm, they reveal payment obligations that exist between two counterparts. This is how a mortgage algorithm looks like. These are the principal cycles, the interest cycles agreed between two counterparts. This is how a savings algorithm looks like. These are the withdrawal events and the interest capitalized events. This is how a swap algorithm looks like when it is triggered. The following are the payment obligations between two counterparts in a swap deal. This is how an options algorithm looks like. This is the price at purchase date and price at termination date. The cash flows here in between represent the payment obligations of the underlying contract to this options deal, which is a simple bond in this case. The list goes on. We can model fixed instruments and derivative instruments using our machine learning algorithms. With such a strong data foundation, a bank can plug in this data to our pre-programmed models such as capital assessment models, credit risk assessment models, behavior assessment models, even forward-looking budget models. Analysts can even build their own models using our workflow. In order that I explained in detail the application of this machine learning in analytics, I chose the following use cases. First up is end-of-day analysis in banks. The analyst can perform exposure analysis at the end of day using such a data infrastructure. The analyst can generate gross exposure of this bank across various industries. Further breakup across regions. Further breakup across ratings, and so on. The analyst can view the net exposure too. One can change the view to a heat map. The dark red is where the exposure is maximum. The analyst can estimate the losses given default for this bank across various industries. Ariadne would be a great tool for the exposure analysis. The second use case we have is market shocks. Such a representation of financial instruments is termed as a smart financial contract algorithm is because the cash flows generated are real-time in nature. In Ariadne environment, smart contracts remain plugged in into yield curve infos, FX rates, stock prices, commodity prices, and etc. as live feeds. This innovation enables contract logic to live outside of a core banking system. This is a huge advantage for analytics and reporting. An analyst can now create what-if scenarios, such as what if the interest rates changed by 1%? What if the long-term rates increase more than the short-term rates? And so on. An analyst can even set up an FX what-if scenario in combination with this interest rate shock and so on. The possibilities are plenty. Here is how a stress-tested capital assessment model of a bank looks like. Firstly, one can generate various value views under stress-tested scenarios. Such as fair value view, nominal terms, IFRS terms, and LGAP terms on various levels of their financial statement. One can assess the liquidity situation not just on the top level but also the sub level. One can drill down to even see the granular values of a contract, such as the event series of this particular mortgage deal, to identify where the problem lies and so on. One can even use a Monte Carlo what-if generator to create a large data set of market shocks. Here you have 1000 market shock scenarios created at random. Such scenarios can now be plugged in into the data model for stress testing. Here are the results of the Monte Carlo simulation. This histogram shows effect of the market shocks on various value views, such as fair value, IFRS, and LGAP. One can even drill down to any level of the financial statement, such as the asset level or the liability level, or even drill down to view the effect of this Monte Carlo market shock for this particular mortgage portfolio. Unlike other ALM tools out there, Ariadne requires just basic information regarding contracts to kickstart a whole lot of analytics, thanks to our smart financial contract algorithms that make this possible. With Ariadne, analysis can be extended to build even forecast or budget models. This is the difference between what we call the static and the dynamic analysis. Static analysis is applying a market shock on existing portfolio. This is what we had done in the previous demo case. What we call as dynamic analysis is applying a market shock on a forecasted model that has new business volume. This is how convenient it is to set up a forecasted budget model on Ariadne. Firstly, one can define what should happen to the existing portfolio, such as rollover, which means the same volume of portfolio gets created after the maturity profile of an existing contract is reached. Roll down, which means no new volume of portfolio gets created after the maturity profile of the existing contracts is reached. Let's say the analyst has a task to generate a budget model that should show an increase in revenue of this bank to about 10% from what it was earlier. In order to achieve this, the analyst will require to simulate new business volume. Simulating new business volume is achieved by defining the granular contract parameters such as type of contract, date of maturity, principal payment cycle, and so on. Also set up yield curve reference data that is required for the new volume to be simulated. For instance, here the yield curve is set to the US Treasury. A machine learning understands such contract parameters and thereby triggers creation of new algorithms in order to create the new volume. Here is the third use case: budgeting and or going concern view. The contract parameters can be set to increase a certain mortgage portfolio in such a manner, wherein 60% constitutes 10-year maturity profile annuities that have a monthly principal payment cycle. Then 40% constitutes to 30-year maturity profile annuities that have a half a year principal payment cycle. Then probably also set up contract parameters on deposits portfolio, wherein 50% constitutes half-year maturity profile bond portfolio that is rated A+, and wherein the other 50% constitutes to 3-year maturity profile bond portfolio that is rated A-. When one executes such a budget model, this is how the results would look like. Now let's look at the results of the forecasted model we had created. This is the forecast of the budget model in fair value terms under various stress tested scenarios. Let's check the forecasted liquidity view, otherwise termed as the going concern view, of this particular mortgage portfolio under various stress tested scenarios. Let's now view the IFRS profit and loss that this mortgage portfolio will result in under various stress tested budget scenarios. One can change the view to a table view. One can export the results of a stress tested budget model into a CSV. Such information would be useful for regulatory reporting. Smart financial contract algorithms of Ariadne are fast because they are machine readable code. We can generate cash flows for 3 million contracts by using a 16-core processor in 16 minutes. Such performance can change quite a few areas in banking technology. By the use of our machine learning algorithms as an alternative to data warehouse solutions out there, saves 60% of the costs in analytics. At the same time, increases accuracy and consistency in analytics and reporting. To sum it all up, Ariadne brings efficiency into analytics and risk management.